So let's talk about numbers. Everybody takes numbers for granted. Numbers give you a quantity. How much, okay? We're used to using numbers. Numbers can be exact. Okay, they can be perfect. 12 is a dozen. Okay, there's no question about how many's in a dozen. There's 12 in a dozen. There's not 11.9 or 12.03. Okay, it's exactly 12. So this is what we'd call an exact number. Okay, if I see 3 people in a room, that's an exact number. I don't have to question my quantity. I don't have to say, well, maybe there's 3.1 people or something like that. It's exactly 3. The other thing that's exact is numbers by definition. And so, for example, 12 inches is 1 foot. That's an exactly 12 inches, and it's exactly 1 foot. This is a precise, I'm sorry, I get ahead of myself, but this is an exact known quantity. 100 centimeters in 1 meter. An exact quantity by definition. A meter is 100 centimeters. A centimeter is 100th of a meter. Okay, so these are perfect numbers. They're perfectly exact. More often we run into inexact numbers. Okay, and these are numbers that come from measurement. From measurement. Okay, so measure, that should be an N there. All right. Okay, so anyone who has ever stepped on a scale knows that you don't know exactly how much you weigh. Okay, it's not an exact number. Maybe it's 150, but maybe it's 151 or 149. There's a range of possibility there. If you read a tape measure, and you find that it's 48 1/4 inches. Well, depending on how well you look, you might get a better measurement under some other conditions. So there's some inexact quality to that. And again, from measurement, any kind of measurement. So whenever we make a measurement, we need to think about the quality of those numbers. Is the quality of the number has 2 attributes. It has precision and accuracy. And precision is repeatability, how close each measurement comes to the others. And accuracy is how close you are to the true value. Sometimes in analytical chemistry you run into problems with accuracy. You really don't know how close you are to the true value, but you do have a good handle on your precision. You know that you will get the same value every time with the same sample. So while this may not let you determine how much there is, it can help you determine the difference between one sample and another. Now, every chemistry textbook, when they talk about precision, uses this figure, or one just like it, where you have the accurate and precise archer. You see that all the arrows are near the bullseye. We have a precise but not particularly accurate archer. The arrows are nicely clustered, but they're not on the bullseye. And finally, we have one with not particularly accurate and not precise. So this is the difference between precision and accuracy. They are not the same thing, even though in common usage we tend to frequently you'll hear people say things that indicate that. That's a very precise measurement. Let's say we've got two thermometers to measure. Okay, we got one that's marked off in degrees. Here's 29 degrees and 30 degrees. If we make a measurement here, we can determine what that means. It means maybe 29.3. Now that last digit is approximated. We know it's more than 29 and less than 30, and we're guessing it's about 0.3 of the way. And another reasonable person might call that 29.2. Okay. Here's a second thermometer, very similar situation. This one's marked in tenths of a degree, though. So we've got 29, we've got our 30, and then clearly not the greatest quality thermometer, but give me the benefit of the doubt here. And now I measure this, and I can see that it's 29.1, 29.2, more than 29.2, less than 29.3. So I'm going to call this 29.21. And again, another reasonable person might look at this same thermometer under the same conditions and come to the conclusion that it's 29.20. The doubtful digit there, the last one, is estimated. And so when you make a measurement, you need to write the number in a way that indicates the precision of your measurement. I'm going to attempt one more thermometer here. And we'll have the 29 and our 30. And this time, I'm going to put it right on the line there. Now, you might say, okay, well, that's 29.5. But I believe that my measurement is somewhat better than that. That's not just 29.5. I'm going to say this is 29.50. I'm adding the 0 to that number to indicate the precision of the measurement. And so this leads into the idea of significant figures. The significant figures, how many figures you have, reflects the quality of your measurement. So here I've got 4 figures. This was the same quality of instruments, so I've also got 4 figures. Four numbers recorded. And here I had a somewhat lesser quality instrument, and I only get 3 figs. Okay, so this is where the concept of significant figures comes from. Numerical values. So a measurement that you make should have 2 qualities. It has the quantity and it also has the uncertainty. And this is what leads us into the idea of significant figures. Okay, when you record a number, record it all. The significant figures, sig figs, is going to be all of the certain digits plus one uncertain.